So good morning guys. Today we are going to solve one more problem on thermal, that is a two-dimensional problem. How to solve a two-dimensional problem? Now this is the problem what they are given. The rate of heat generation in a slab of thickness 160 mm, that is K will be equal to 180 watt per meter Kelvin, is 1.2 in 10 power 6 watt per meter cube. Okay, if the temperature of each surface of the solid is 120 degrees Celsius, compute and plot the temperature distribution across the wall. Find, first one is temperature and at the mid and quarter planes, temperature gradients at the mid and quarter planes. So just observe here, there are the two things you should calculate: compute it and you have to plot it. Where what you want to compute it and plot it, that is temperature at the mid and quarter planes or temperature distribution across the wall. That is the one thing. Next one is you want to determine, that is temperature at the mid and quarter planes and temperature gradients at the mid and quarter planes. Now how to solve this? See, first I will go theoretically how to solve this problem. Now this is what the problem given, entire thing I have written here, a slab of 160 mm, this is L equals to 160 mm, that is thickness is given, that will be taken as L, 160 mm, that is 0.16, okay, it is here is given. Then wall temperature is given, okay, TW is given, that is 120 degrees Celsius. Down K is given, K will be equal to 180 watt per meter Kelvin. See here the heat is, the temperature is flowing along the X direction. Now Qg is given, that is heat generation, volumetric heat generation, that is 1.2 into 10 power 6 watt per meter cube. Area is not given, you can assume area will be equal to 1 meter square. Now what you want to determine? You want to determine temperature at quarter and mid planes. Now if you take this is L, what is the quarter? L by 4, 3L by 4. What is the mid? L by 2. Now you want to calculate what is the temperature at L by 4, what is the temperature at L by 2, what is the temperature at 3L by 4. That is the one thing. Similarly, you should calculate what is the gradient at L by 4, what is the gradient at L by 2, and what is the gradient at 3L by 4. That is nothing but we are taking that as a T1, T2 and T3. Now how to solve this theoretically? Just go to theoretical. So just observe here, a plane wall with a heat generation, theoretical solution. This is how you can calculate the theoretical solution. Now you can go through theoretical solution already, because you're having in a subject called heat transfer. You can already solve similar kind of problem. You can just observe, okay, how to solve theoretically. See, they calculate temperature L by 4, L by 2, 3L by 4, that is 136, 141.3, 136. Similarly, they calculate a gradient, that is dt by dx at 3 locations. Okay, that is T1, T2, T3. Now how to calculate? This is what theoretical solution. Now how to solve the same problem in your FEM? See, how to model it? See, you have to model this as a two-dimensional element. Once, because volumetric heat generation is given, you have to apply over on a volume. Because of that, you require it, you have to shoot minimum means you should require a two-dimensional element. Now 160 is the length, that is nothing but your thickness. Now 10, height is not given. You can assume the height, because temperature, wall temperature is constant, because you can assume your height. Now I am assuming heat as a 10 millimeter, 160 millimeter is the length, and height will be 10 millimeter. Now here 2 division, 32 division, it is only for your FEM analysis. See, we want to calculate at L by 4, 3L by 4, L by 2. For that purpose, you should use a number of divisions should be known. See how many number of divisions you want to use. All those things you should, just for your remembrance purpose, you can keep it this 32 and 2. Now what is the model, FEM model I want to use it here? FEM model if you want to use for area, always I want to use a plane element. Plane element 55 I want to use. Option should be plane thickness. Now I will show how to solve the same problem in your Ansys. Now minimize this, open your Ansys. Now how to solve Ansys, just we will see here. First go with the preferences. Use your thermal, you are solving a thermal problem, use thermal. Now preprocessor, element type, add edit delete, add. Now go to solid, quad 4 node 55, just give OK. Now in options, you should change your plane to plane thickness, OK. Now close this, minimize, go to real constants, add edit delete, add. Now OK. Now in this thickness, give 1 meter, you can give it, just you can assume it, close. Now minimize this, go to metal properties, material models. We have only one value you have to give, that is conductivity, isotropic. What is the value of conductivity given? 180 watt per meter Kelvin. Give OK. Now material, exit. Then after this, go to your modeling, create. Now what do you want to create in a two-dimensional model? Directly go for creating area, rectangle. Use 2 options. By 2 corners I am going to use, because I will take my first, that is initially it will be on 0, 0, 0, width I know 0.16. I had given, that is thickness is given 0.160 mm is the length. I am taking it as in meters, 0.16. Height we have to assume it, that I am assuming 0.001. Okay, give OK. Now this is what the model you have created. Now after creating your model, next step is you have to go for meshing. say meshing, what we have to do it means we cannot divide here quarter, all those things. While dividing your number of elements, you should be given a some value that you can remember. That means, for example, you should given a equal number of elements. That means if you give 32, you can easily say that what is the quarter for 32? 8. 8, 16, 8 will be one quarter, 24 will be one more quarter, and 16 will be mid. Like that, you should give an equal even number. Okay, even numbers. For example, if you give 24 means you can clearly identify that 12 will be your mid, 6 will be your quarter, and one more 18 will be your quarter. Like this, you should divide. For that purpose, you require some even number of divisions you should do. Now, how to do meshing here? Go to meshing. Okay, there is an option called size controls. Manual size. There is a, see, I am controlling the mesh here. Manual size, lines, picked lines. Now I'll pick top line and bottom line because that I required. Now I'll take that as a 32. Now why I am giving 32 here? Clearly I can say that which is mid. If I give 30, 15, then what is quarter? 7.5. How to count 7.5? It is not possible. For that purpose, give a number, even numbers, 32. Now see, it has been divided into 32 number of elements. Now I had not done this. Now once again go to picked lines. Now select these two lines. Okay, give here only 2 is enough because it is not the major importance. Important will be along the x direction. How was your heat transfer? Give OK. Now after this, now you just discretized the continuum into number of elements. Now mesh it. To mesh it, go to mesh, areas. Now free, what you have area, pick the area, give OK. Area selected and give OK. Now it has been meshed. So after doing your meshing, now minimize this. Now go for applying your boundary condition. So you have option of applying boundary condition here itself, that is loads, or in previous problem where I had explained solution, define loads. Go define loads, apply, thermal. Temperature is, we know the temperature. Temperature where? On these surfaces, correct? Now select temperature on lines. Now go to this line and select this line. Give here, what is the temperature? Temperature given is 120 degrees Celsius. Just make it 120. That is temperature is given. Now see, temperature is applied. Now apart from temperature, is it anything is given? Heat generation is given. Heat generation on where we could get volumes, but volume is not there. Here area is there. We should give area because our thickness is one that is not visible here. Because of that I am giving on areas. Now select this area. Give, it will become as a volumetric heat generation. 1.2 e to the power 6. 1.2 in 10 power 6 is given. You can give 1.2 e6. Give OK. Now heat generation is given. Now heat generation is given, you are given temperature. Anything you want to give it? I think we are given all the values. Now go for solve current load step. Give OK. Now solution is done. Close this and close this. Now where you want to check your results? Go to general post processor. General post processor. Now first click read results. Just click last set. Okay. Now go to plot results. Contour plot. Nodal solution. Now I am just displaying the results. Nodal temperature. Now just check it here. This is what the temperature. So maximum we are getting at 141.33 and 120 will be your surface temperature. But what we require at L by 4, L by 2 and 3L by 4. See, I cannot get here how L by 4. I cannot get from here. But I know the temperature I obtained. Similarly, if I want to check your gradient, just click on thermal gradient along x direction. Give OK. I can get even here. See 516. Here 516, here also 516. One is minimum value, minus 516 here, plus 516 here. But how to check exactly at the mid quarter? See, for that you have to go for list results only. List results. Now in list results, nodal solution. Now go to DOF, nodal temperature. Just click here. See, if you go here, nodal temperature. Now see here, it is giving. See, in node number 1 and 2, what happened? Generally in the problem, see, this is the first node because while creating your continuum itself, you have created 1 and 2. It will take to create 1, 2, 3, 4. 1, 2 will be over here itself. For that purpose, leave 1, 2. Leave 1, 2 here. Now count from this 32. So if you count from this 32 means that is your 34. Correct? 32. What is the mid for 32? 32 mid for 32 will be 16. 16 plus these 2. What is the value? See, you select your 18 node. This will be your mid value. 18 will be your mid value, that is 141.33. Similarly, what is your quarter? Quarter will be 32. What is the quarter? 8. Already 2 nodes will be formed initially while creating your area itself. 1, 2. That means what is the quarter? 10 will be your quarter, that is 136. That means at L by 4 the value will be 136. At L by 2 the value will be 141.33, that is 18. Okay, similarly you want to get one more. What is the one more quarter? 24 will be one more quarter plus 2, that is 26, 136. This will be your values. That means at 24 you should, 24 means you should plus 2, 26 you should check, that will be your 136. Then at this mid means 18, you should check 141.33, that will be your mid value, and one more quarter will be 10, that is 136. This is what your temperature value. Similarly, if you want to check your gradient, check for same values, whatever I told you, check for same. See here, check for same. Now see along x direction means 10. What is 10? 266.67. Then what is 18? Almost equal to 0. Okay, that is 10 to the power minus 6. Then what is next one? That is at 26 here, minus 266.67. If I want to check these answers are correct or not, already we have seen here, correct? Just go for your backslide. So just see here, what is this? 136, 141.3, 136. This is theoretical answer. Similarly here, this is the answer. 266.67, 0, minus 266.67. This is how you can get the solution here. But this is how you can find the results. That means you find the results. But what is the one more thing is given? Plot. How to plot the graph for this? So to plot the graph for this, go to plot here, keep plot results. That is contour plot, nodal solution. Keep it as a temperature. First keep it as a temperature. Now how to plot the graph? See, to plot the graph, there is one option called path operations. Go to path operations, define the path. See, from where to where you want to click, you want to create your graph. See, from node 1 to node 2. Now by nodes, select node 1, select node 2. See, node 1 and node 2 is selected. Give OK. See, give some name for this path name. For example, I am giving TR. Okay, TR I am giving. Some name I had given, that's it. Okay. Next, after this, now what do you want to make? Plot paths. Or map onto path, plot path item. See, we have a lot of things. First, map onto path. See, what is map onto path? What do you want to plot it? See, I want to plot one is temperature. For that, I will give temp. Here, I am giving a name, temp. I want to plot a temperature. Give OK. Sir, give apply, because I want to give one more. I want to plot it. Flux and gradient, I want to plot it. What? Along the x direction. Click the here. What is this? I will give this gradient. For this, I will give a gradient. Gradient, I want to plot it. Give OK. Now see, I had first what? Defined the path. Then I had mapped what I want to draw it. So that is what? Map onto path. Then plot path item. See, plot path item. See, there are two options are there. One is graph, one is a geometry. Now I'll show how to draw first the graph. On graph. Now what is the two values I want selected? See, one I want to plot temperature. Just observe temperature. See, this is how your temperature plot. Now observe here 120. That is what? Your surface temperature. Now see here. 0.016, 0.32. See, from this graph also you can get that exact value. See, 0.16. What is the mid of 0.16? 0.008. Just go here. See the temperature 141.33. Similarly, what is a quarter? Somewhere here you can get it. 136 will be your quarter. You can, using this graph also, you can determine the solution. Okay, that is the one thing. This is what? Temperature plot. Now, how to draw your this one? Go to once again on graph. Now, remove temperature. Click gradient. This is your gradient graph. This is your gradient graph. Okay, 516. See, 0 will be at the mid, 0 will be at the mid. This is 516. See, where you require 0.03 to check the answer. See, mid you can check the answer. One more quarter you can check the answer. This is how you can using your graph method. Same plots can be done it using your geometry. On geometry, that means it's a geometrical view. Click temperature, temperature. See, this is your geometrical view. That is what you're getting. Okay, this is geometrical view. This will be 141.3. Like this also you can plot it. Similarly, on geometry, if you want gradient, same thing you can do it. Gradient. See, gradient also you can get it. Just fit it. This is out of the box. Fit it. Okay. Yeah, just you can zoom it. Fit. Okay. Now you can take it here. You can get, this is what? Gradient plot. Got it? This is how you can plot your, see, this is called plotting. That is on graph and geometry. I am showing the plotting. See, what initially I had shown, that is checking your plot results and list results. I am showing values, how to find the values. Okay, this is how you can solve in a two-dimensional problem. Thank you.